Good morning, everyone. I hope that you guys are having a good start to your day. Um, I hope that you got your coffee. You aren't too hungry for lunch quite yet, but so today I don't really have too many announcements or anything like that. Um, I do have to, one thing that I said that I was going to do, and I'm still planning on doing, hopefully today, is to Um, one, add a little bit of a label to or detail about the quizzes. So a description, something like, the questions in this quiz will come from these PowerPoints. So I'm going to add that hopefully today, and then I still got to, I don't know what the best way to name the notes versus the quizzes. I'm still sorting that out. I know I've kind of been dragging my feet on that. I promise I haven't intentionally been dragging my feet, just working on other things have been a little bit higher priorities. Like I said the other day, you guys are going to have a practice exam up on our Canvas page by the end of this week. So expect that Friday. Um, then, I know that I've got office hours at 12:30 today, and you've got the link on our Canvas page. But in the event that you can't make that, just send me an email and we can sort something else out. Now, I did have some students in my other class. They were having some issues kind of navigating our Canvas page, and I guess this is an announcement. I just want to show you guys uh, where to get information. Um, so the way that I navigate our Canvas page is I just use a web browser. I do not use the app. And so your display might be a little bit different from mine in terms of what you're, brought onto first. But I've switched this to student view, so yours should look very, very similar to this. So basically, the Canvas page just has a Zoom link for our lecture, Zoom link for office hours, and then a couple of columns. The number of weeks, we have a grand total of 16 weeks in the semester. And then next to that is the date or dates. And then in the next column, you'll find recordings. So the link to our recorded YouTube or sorry, recorded lecture that's linked to my YouTube. The activities, I post those, I'll have those links on Mondays so that those are just like populated there. And then section or the content that we're working on. Here's your PDF, here's your PowerPoint. And for today, for example, I still have to add some more of those. And then we've got our first exam on February 12th. On February 10th, we'll have a review. So we'll kind of go through everything and give you, maybe address some of the questions from the practice exam. Then one other thing that I've added is in this very last column, which is titled Content. I started doing this on the 22nd, and that is I've added a day's summary. So basically, what were the high points for the day? If you click that link, it will take you to a page that says, hey, here's, the 22nd. Um, what were the important points of the day? And then what are some study suggestions? So the important points on the 22nd, I tried to make it as simple as possible. Here's 5 different things. Here are some of the things that we talked about. And then, some light suggestions, sketch Lewis structures and skeletal formulas and maybe make some flashcards. Memorize, memorize naming conventions, so like prefixes and suffixes. And then, yeah, so that's what I'm planning to do for, I did that on the 27th, so I did that for Monday's class as well. So, um, those will be kind of your active like learning objectives. What did we do on this day? And what was I supposed to take away from that? Uh, so I hope that that will narrow narrow your narrow your focus a little bit. And then I think that yesterday, great, I'm happy. I opened up your old quizzes so that you could see the correct answers on those quizzes. Um, so you can look back at those. So then whenever it comes to like doing your own study for the exam, you'll have the old quizzes, and then you can also look at those like day summaries. And I'm going to look at the day summaries and use that to kind of put together questions for the exams and stuff and content and things that we cover. What I would do if I were you is I would take those days summaries and be like, okay, you gave us 5 important points. Could I write a question? I being you, students. Could I write a multiple choice question reflective of one of those things? Um, and I think that will be a helpful study tool. So then you're just kind of like, you're kind of writing your own exam. Um, and then yeah, I think that's it. Uh, so I've got a couple of poll questions today. And so I wanted to go ahead with first three. These first three are going to be starter questions. They're kind of you know, looking back at what we did last time. And so my first question is up, and it is, how many electrons make up a lone pair of electrons? We've got one, two, three, four. There's no such term. A pair is a fruit, so zero. Okay, we got, and while you're, oh, actually, I'll go ahead and wait. I'm going to go ahead and end the poll. We're at about 45 seconds. So now we're going to go on to the next question. Um, Most everyone got it right. 84% of the class got it right. The answer is two, a lone pair of electrons. So two, pair, just like a pair of shoes, a pair of electrons. While I'm pulling up the next question, one of the things that I want or before I pull up the next question, one of the things that I want to emphasize is when it comes to poll questions, I don't use it as um, I don't want you guys to think about poll questions as like, oh, I have to answer this. If I don't answer this, I will fail. I want you to look at poll questions as, okay, these are important points that Joel's brought up, that he repeatedly brings up. These are points of emphasis. I should think about this. And I like to get a sense of where everyone is, where the class is as a whole. So if there's a question where, everyone answers the exact same wrong answer, or everyone answers equally wrong answers, that's something I want to address and kind of, reevaluate. Um, my point in that is what I'm looking for whenever I look for poll responses is I'm looking, did you answer a couple of the questions for the day? Today we have a total of 7 poll questions. Um, if you answer like one and immediately leave the Zoom, I'm probably going to reach out to you and say, hey, I saw you answered one question. Um, you know, please don't let that happen again. Come to class, engage. So I know that that's kind of like gray area language. My point is, though, that poll questions are mostly like completion, but they're also like, I want a sense of where you are. Okay, so here's our next starter question. A molecule classified as an alcohol will have what group? OH, NH, CH, CH3, or F? An alcohol. Now, whenever I think of an alcohol, specifically an organic compound that has an alcohol that's been specified as this is an alcohol, for some reason, what always pops into my mind is I look at the word and I see OH in the center of the word. And that's not like a tricky or clever mnemonic or anything, but ever since I learned what an alcohol was, that's resonated with me. So anytime I hear it, I'm like, oh yeah, I can see an alcohol, OH, right there. So the correct answer is OH. Now, will alcohols also have carbons? Yeah, but that's not what's going to define them as an alcohol. Third question. Which of the following is a 6 carbon aromatic compound? So an aromatic compound, if you remember, an aromatic compound has those alternating double bonds. I'm going to draw it on the screen here, what this six carbon aromatic compound is. So we've got six carbons. By it being aromatic, another thing that kind of, or something that sticks into my mind, whenever I see ARO, for some reason my brain goes to around. So then my mind goes to ring, or a circular or a cyclic molecule. So here's a six carbon molecule. What I've just drawn right here is cyclohexane. But then whenever I put these double bonds in, I've got alternating double bonds. So this right here has alternating double bonds, which aromatic compounds have, is cyclic, which is true of aromatic compounds. So this is our aromatic compound. So when we look at our different answer options, hexane, septane, squalene, Alex, you're absolutely right. So this is kind of one version. The better version, which Alex is, thank you very much for pointing out. What we got to do is put the circle there. So there is our cyclic molecule that has those alternating double bonds. So I'm going to erase that, and it's this guy right here. That compound is known as benzene. Okay, thank you guys very much for answering that. Now, a lot of the class answered hexane. There's a couple of issues with that one. Hex, sure, it's got six carbons, so you saw that, but it's not aromatic. So let me go ahead and draw. I'll spend a minute on this one. Don't worry, guys. Okay, so hexane. Let's break that down before we. I'm going to close the question, so I'll close that. And we'll work on this one together. Hexane. What do we know about hexane? How many carbons does it have? Six. Okay, it's got six carbons. Okay, so that addresses our HEX. What about ANE? What does that suffix mean? ANE tells us we only have single bonds. Great. Now, with this name, hexane, well, what I'm going to do is I'm just going to draw the kind of backbone. C, 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 C. It's 4, 5, and 6. If I added a bunch of hydrogens to that, would that satisfy the like hexane? Alex, just a second. I'll get to that one. That's a great question. So right here, well, this is, if I had that saturated with hydrogens, that would be hexane. There's nothing about this. So if I were, yeah, hexane there, and then if I drew it like this, is, so I'm going to put A and B as my two molecules. A is hexane because it has six carbons and nothing but single bonds. B, yeah, it's hexane, but we could add something to give us a better definition or a better name for molecule B. What would we add to that? Cyclo. So B would be cyclohexane. Okay. So we've got hexane down here as molecule BA, and then cyclohexane as molecule B. Okay. That ANE suffix is a really important part about this. Now, if we were to draw, there's a couple of details that we have to remember about an aromatic compound. An aromatic compound is always going to be a ring. It's a ring and it's got alternating double bonds. Okay, so one of the tricky parts about this is that benzene is one of a few molecules that I'm going to ask you to know that common name. So the prefix benz, Alex, you have a fantastic question of how do we know benz part of benzene means six? And my answer to that, and I don't mean to sound like cold or blunt or anything like that, but that's just one of those common names that you have to kind of commit to memory. Now, I think that if I remember correctly, cyclohexane has a kind of more technical name, showing that I think that it's 1,3,5 cyclohexene. 1,3,5 cyclohexene. But benzene is the better name because if you remember, when we looked at benzene, we had two different ways that it could be drawn. And the more accurate is just that we've got the circle in the middle. Okay, so for those of you who said very confusion, did that clear things up a little bit or at all? And you can send me a private message and say no. Okay, I got a yes there. Alex, that's a fantastic question. Some of it is just a matter of like industries. So benzene is something that is used in tons and tons of different industrial applications. So it's almost like over its like the frequency that it got used or the frequency that benzene is a part of different industries, it's almost like the people within those industries were like, I don't want to say 1,3,5 cyclohexene every time that I have to say, hey, get me some of that to add to this reaction. So yes, Javion, that's it. Yes, pretty much. Yeah, absolutely, Alex. That's a great analysis. Okay, cool. Great. So benzene is one of a few that it's just like we're kind of avoiding the conventions and we're going with that's the common name that we got to use. So thank you very much for these questions. These are fantastic. I, at this point, I don't think that I've introduced any other compounds that you have to memorize those common names. But there will be some more over the course of the semester. In the coming like in the next few days, we're going to talk about the building blocks for proteins. Those are known as amino acids, and we'll get into those a little bit, those common names. And if we were to look at the technical names, um, we will be in a much better place with those than anything else. Because the technical names for amino acids are just like 1, 2 amino alpha. It sounds like, someone in the Air Force is talking to the ground control. 136 Alpha Bravo, 17 into descent. I'm not a pilot or in the Air Force. Okay, so functional groups, part two. Now, we've got some more functional groups, and we need to know those names. So far, we've talked about alkanes, alkenes, halogenated hydrocarbons, alkynes. We've talked about alcohols and aromatics, and we've also talked about alcohols and how they interact. So if you're like, what have we done so far? This is a good place to think about, okay, this is where I'm going to ground my knowledge. And I'm going to build out from each one of these things, but this is what I'm rooted in. Now, what we're going to introduce today is a couple of different ones. And we'll also look at some chemical reactions. Now, if you look in the upper left-hand corner, you'll see phenol, epoxide, and ether. Then in the lower right-hand corner, and one of the things about the epoxide and the ether is what I see, and I want you guys to see, is we've got single bonds going to an oxygen. Um, So I've got a poll question for you guys. Looking at those epoxides and phenol, how would you classify an ether, an epoxide, or a phenol? Thinking back to what was our first poll question today, and that was about lone pairs of electrons. And just as like a little bit of a hint, but also a, hey, don't forget this, this epoxide, it's got two lone pairs of electrons. And what do we know? And then this hydroxide on phenol has two lone pairs of electrons. What do we know about a molecule that has lone pairs of electrons on an oxygen? And you know what? Um, right now we've got 17 responses, 18, 19, and it's almost a minute. 4, 3, 2, 1. 95% of the class answered polar. You're absolutely correct. So we would classify these compounds as polar compounds because they have those lone pairs of electrons. I think that's a pretty good rule of thumb to follow. If something has, yeah, they're clustered together. The oxygen has more. Absolutely. Great responses. That's okay. I'm sorry. Are you, Maria Jose, are you on the app? Because I think that sometimes people have like, they tap their screen and the app swings around, and at least on a mobile device. Um, we'll have some more questions, so hopefully you can sort it out that way. Um, so anytime you see that oxygen with some lone pairs of electrons, think that's probably a little polar. So when you look at that aldehyde, um, or ketone or carboxylic acid, those all also have an oxygen with some lone pairs of electrons. We're going to get into each one of those a little bit deeper, but then we'll also, there we go. Um, we're also probably going to look at these compounds known as esters and thiols. But first, let's get jumping on phenols. Now, phenols, it's kind of funny because phenols and aphenol are, this is like a square is a rectangle, but a rectangle is not a square. Because this compound right here is known exclusively as phenol. Now, when you look at that compound, I got another poll question for you. But when you look at that compound, I want you to kind of think about the parts of it. So that specifically is known as phenol, but there are also other compounds that have that same ring and that hydroxide group that are a part of the class of compounds known as phenols. So another way of putting that is phenol is a phenol, which kind of makes sense. Um, but phenols, by kind of definition, they are organic compounds with a hydroxyl group attached to an aromatic compound. The simplest and best and easiest is, spoiler alert, benzene, which is our six-membered ring down here, and an OH group. Now, what this molecule can do is it can lose this hydrogen and get a negative charge. Now, what that means is that this can get even more polar. So phenols are stronger acids than alcohols and are known to be toxic. Phenols can also hydrogen bond because of the hydroxyl functional group. So think about this, and the way that I want you to think about this is I want you to think about phenols as strong acids. And the significance of that is what they can do is they can basically break down compounds in your body. So they're strong acids and they can hydrogen bond. Those are the two details that I want you to know about phenols. And this is really what I want you to know about the specific compound, phenol. So phenol is a specific molecule, and phenols are a class of compounds. more times than not, we will talk about phenol. I'm not going to throw many, I don't think I'll throw any other phenols at you. Instead, I'll just ask about phenol, that specific one. Okay, so when you see this molecule, you should think, well, it's got that lone pair of electrons, or those two lone pairs of electrons on that oxygen. So it's almost like a polar version of benzene. Or you could say, let's rephrase this, benzene plus polar group. All right. Now, 88% of the class got that right. They said benzene plus an alcohol. And yeah, great job. So benzene plus alcohol. Where is phenol used? If I remember correctly, phenol is it's commonly used as a solvent. And what I mean by that is, have you ever, used something that you add water to and it doesn't go into solution, it doesn't dissolve? Um, that's a good indication that that substance, well, is referred to as insoluble in water. But phenol, I think, can make quite a few things soluble. Um, so that's one place in which phenol is used. It's also used in lots of industrial applications. And so you could say it's like industrial apps, applications, not appetizers. So like oil and gas industry in particular. It's used in making, I'll say making medicine. And then it's also used in skincare, um, skincare treatments. So that's one way in which phenol is used. Then our next class of compounds, um, ethers and epoxides. An ether is a molecule with two organic compounds attached to the same oxygen atom. So these R groups right here are our organic compounds. So this is basically um, our oxygen and then two organic groups that come off of that oxygen. Now, these uh, ethers can be an open chain, which is what we see here with ether, with this model ether. So think about, I'm going to erase this. This is our model. Anytime you see this R, well, think about that as a hydrocarbon chain. So it could be H3C, it could be CH2CH3. Um, that's that's basically what we have there. So this ether is our model. Now, another or an example of an ether is seen right here. This is known as diethyl ether. We've got this oxygen in the middle, and then we have these two organic chains coming off of it. These two hydrocarbon-based chains coming off of that central oxygen. Tetrahydrofuran is an example of an ether. 1, 2, 3, 4. This is a five-membered ring. Five atoms make up the ring. Four of them are carbon, and that's where our tetra comes from. This hydrofuran, that is a specific name that's designated for compounds that are five-membered rings with oxygen as one of the members. Now, last but not least, is kind of a unique example. So ethers can be ringed, which is what we see with tetrahydrofuran, and diethyl ether. These are both ethers. One of them is open, and one of them is a ring. Now, a three-membered ring that is an ether is also known as an epoxide. So ethers that are a three-membered or three-atom ring, this is a unique name saved just for those. Epoxide. Anytime you hear epoxide, you need to visualize this right here. Now, ethers are used for a number of different things. Um, One, diethyl ether, that can cause you to faint, lose consciousness. When you inhale it, tetrahydrofuran, also known as THF, is extremely explosive. Now, this unconsciousness, they're used as anesthetics. So drugs that make you pass out before surgery or something like that. Um, that's what they're used for. Diethyl ether was an early anesthetic because it would just kind of knock people out. All right. Now, our next class of compounds or our next group are our aldehydes and our ketones. I've got a poll question related to these, which I'm going to bring up in just a second. What I want you to notice about an aldehyde and a ketone is that they both have what's known as a carbonyl group. These are two families of organic compounds that contain a carbonyl functional group. Now, I've got my poll question that I'm going to pop up right now. The oxygen in an aldehyde and a ketone have the same number of lone pairs of electrons. Kind of dissect those. Look at what those two molecules look like. Give you another 10 seconds or so. Got pretty good turnout on this one. And we're going to go ahead and end now. 73% of you said that it's true that they have the same number of lone pairs of electrons. And you're absolutely right. This oxygen right here, one lone pair, two lone pairs. This oxygen on your aldehyde, one lone pair, two lone pairs, one lone. And your ketone, same thing. So what makes an aldehyde and a ketone different from one another? If you want to add to the chat and answer the question, what makes an aldehyde different from a ketone? Well, they both have a carbonyl carbon. They both have a carbonyl oxygen. But what makes them different from one another is what that carbon is attached to. An aldehyde has one R group and one hydrogen. A ketone has one, two R groups. Now, you might be curious about, well, why do I care about aldehydes and ketones? What's significant about those? These are compounds that are found in sugars. In addition to being found in sugars, they are found in proteins, and they are found in DNA. So these compounds are very important for basically life. Um, Now they have a yeah, that's ketone bodies. If you've ever heard of DKA, has anyone ever heard of that in a medical context? DKA. If you have, add what you think it is to the chat. I'll give you a second, and I'm gonna drink some water. Diabetic ketoacidosis. So it's related to diabetes. And ketones. if you've ever had anyone who talks about, being on a high fat diet, well, then if somebody is on a very high fat, low carb diet, what are they trying to get into? So, yeah, ketosis. They want to get into ketosis so that their body is using ketones their body is extracting energy from ketones more so than sugars. Ketone bodies are the molecules that are used for ketosis. And so if somebody gets into ketosis, then they know that they're in ketosis because you have lots of ketones that accumulate in like your urine and your waste. Okay, so that's one of the things that people monitor. Now, diabetic ketoacidosis versus ketosis, they're different. Not a physician, so I can't really speak to what makes them so much different. But one of them is potentially life-threatening, whereas the other is not as hazardous. Okay, our next class of compounds are carboxylic acids. A These are organic acids that contain a carboxyl functional group. Now, you might be looking at these and saying, oh, well, isn't that a carbonyl carbon? Yes, it is. This right here is a carbonyl group. So too is this. Now, a carboxyl group is this right here. This molecule, as soon as you put that R group onto it, that is considered a carboxylic acid. So this is the functional group, the carboxyl. This whole thing is a carboxylic acid. Carboxylic acids are very important for tons of different reasons. For example, on our next slide, we see carboxylic acid can react with an alcohol to form a compound known as an ester. So anytime you see this C, sometimes it's written as COOH. When you see COOH, think carboxylic acid. That will react with an alcohol. And oh, no, great question. So in our group, that's organic chemists use it as a placeholder. And what I mean by that is it's almost like it is what X is in algebra. When you see R, just think CH3. Now, that is like the simplest R group. It could also be CH3, CH2. Sorry about that. I just think of R as, like I said, a placeholder. You can substitute any hydrocarbon in there, basically. So, you could have, let's say, I'm going to go ahead. Sure thing. I'm going to give you a specific acid. Here we go. And then there we go. Now I'm going to switch colors. Let's go with this guy right here. CH3. No, I'll go with CH2. H2. C. H2. C. H3. And then over here, we've got CH3OH. So if we had these reactants, this would be, and we can go ahead and put the name together for this. Thank you very much for asking because that kind of triggered me to think about this. We've got how many carbons in our acid? 1, 2, 3, 4. We've got 4 carbons there. So what's our prefix for a 4 carbon molecule? Absolutely. Bute or but. Now, if we want to know this as like to add this prefix, if it was a 4 carbon molecule, we would say it's butane. What we call this instead of butane, because it is a carboxylic acid, because it's an acid, we drop the E and we add oic. acid. So that is butanoic acid. That's the name for that molecule. So when you see butanoic acid, think it's four carbons with a carboxylic acid. And you could kind of go with your same prefixes. If you see one, if you saw this, CH3COOH. Well, what would we call that? That's one, two carbons, ethanoic acid. Does anyone want to go ahead and add to the chat what your guess is for a three carbon carboxylic acid? So this compound right here. Propanoic acid. Great job. Awesome. Okay, so now what we're going to do is we're going to look at what is the result from mixing butanoic acid and this alcohol. What's the name of that alcohol that I drew there? We got a single carbon in an OH group. What would we call that one? One carbon, our prefix is meth. Methanol, perfect. You got to be honest. Anytime I see methanol, my first mind is, or my first thought is to think about cigarettes, and I think, is it menthol? No, it's not. Methanol and menthol, different. Okay, so we got methanol reacting with butanoic acid. What would that look like? Well, what's going to happen is we're going to make an ester. And the model that's shown here basically says that this OH group reacts with this hydrogen and makes water. So that's our color pattern there. That magenta OH reacts with the green H to make HOH or H2O. What that leaves behind is we have our chain here. So we've got CH3, CH2, CH2. Then we've got our carbon with a double bond, and then O, CH3. And just to clear up any confusion or curiosity, is it significant that I wrote my H3 on the right-hand side versus on the left-hand side? It's not. It doesn't really matter. I just did it for the purposes of organizing in the space, so it doesn't really impact there. Now, this makes an ester. This ester, that was kind of our whole point here. Esters are formed by replacing the hydrogen of a carboxylic acid. So we replace the hydrogen in butanoic acid with the alkyl group, so the carbon group of an alcohol or of phenol. And the significance of this is that with esters, we make fragrances. So what we did was we reacted butanoic acid and methanol. And in the process, we made this compound right here, methyl butyrate. Methyl butyrate has a fragrance of an apple. Sorry, Alex, you're absolutely right. We make an ester and a water is left over. Thank you very much for asking that and clarifying that. Um, so if we had reacted ethanol with butanoic acid, then we'd make ethyl butyrate, which smells like a pineapple or tastes like a pineapple. So these are all the different things that are made from different carboxylic acids and alcohols. So that's effectively what we've produced. So when we think about like things that, sorry, when we're looking back on this and our previous lectures, our previous lecture, we talked about making aromatic compounds, or we talked about aromatic compounds. They have odors. Aromatic compounds and esters are both compounds that have odors or odors or flavors. Our next and our second to last group are derivatives of ammonia. Now, ammonia is a household cleaning agent, and it has a formula of NH3. It is an example of, or it's kind of the foundation from which the class of compounds known as amines are made. Now, when one or more of those hydrogens on ammonia are replaced by an alkyl group, like this R group, that can be replaced with CH3, just as an example. So when that R group is replaced by something like that, we make an amine with one R group, an amine with two R groups, or an amine with three R groups. Now, like ammonia, amines tend to be basic and they have similar odors. Now, the names and what I want you guys to remember about amines is that if you have one R group, this is known as a primary amine. Does anyone want to guess what an amine with two R groups is known as? I'll draw the symbol. And likewise, an amine with three R groups. Add to the chat what you think those are. Secondary. And then third, tertiary. Perfect. Done. Good job. Okay, so amines they can have purposes similar to ammonia as a cleaning agent. Now, in terms of an application, amines can react with carboxylic acids. The significance of an amine reacting with a carboxylic acid is it makes a new functional group known as an amide. Amides have nitrogen bonded to a carbonyl carbon. The amino acids proteins are linked by an amide linkage. So we've got a carboxylic acid here, which we've seen previously. And all that we're going to do is we are going to take this OH group right here and drop that. And then on our amine, we're going to take a hydrogen and drop that. Raise your hand if you think you know what we're making from OH and H. And yes, I know I can't see you, but I can see that everyone's raising their hand right now. I know it. I know it right here in my heart. So go ahead and add to the chat, what are we making in addition to an amide when we react carboxylic acids or a carboxylic acid with an amine? Water. Water is a byproduct of this. Now, when ammonia reacts with a carboxylic acid or a primary or a secondary, that's what we're going to get out of this, an amide. Now, this right here is super important for the purposes of proteins. And we're going to get into proteins in a little while, but what I want you to know is that an amide results from a carboxylic acid and an amine. So just as a little bit of a review for today, just going to jog through these kind of quickly. What have we talked about? Phenols. We talked about phenols being basically benzene plus an alcohol. We talked about ethers, and we talked about epoxide. Epoxide and epoxide is a special case of an ether. It has two single bonds going to an oxygen, but what makes epoxide unique is that it is a three-membered ring. We talked about aldehydes and ketones. These have a carbonyl group, a carbon with a double bonded oxygen. That carbonyl group is found in your aldehydes and your ketones. It's also found in a carboxylic acid as well as an ester. Carboxylic acid is a compound that will react with lots of different things. If a carboxylic acid reacts with an alcohol, we're going to form an ester, and esters have great smells. If a carboxylic acid reacts with a amine, we're going to form an amide. So this meeting and this lecture, a little bit more than our previous one, we're focused a little bit on what are the how do our different functional groups react with one another? Absolutely. Sorry about that. We're looking at how these different functional groups react with one another. So when you're thinking about and anticipating, like, what should I do to prepare for the test? And what sorts of questions should I anticipate? Well, I think some really good questions are identifying the molecules. So if I show you something and maybe draw a box around something and ask, what is this functional group? Or how would you classify this molecule? Those are good questions. But then, in addition to identifying, being able to say, well, what's the product that results from these? So those are going to be a little bit more complicated, and there's probably not going to be so many of those, in part because we don't have that many reactions. We've got amide formation and ester formation. What's at the heart of both of those? Well, a carboxylic acid. Um, I think yeah, that's pretty much the majority of it. I'm going to show this last poll question, so go ahead and answer this before you depart. Other than that, though, I hope you have a great day. I'll be updating some stuff on our Canvas page. I've got office hours available through the link starting at 12:30. I'll post today's lecture a little bit later as well as the notes. Um, and then I hope you have a great weekend and I'll see you guys on Monday. Make sure that you get your quizzes and your activities done. Sunday at 11 p.m. And if you want to hang around, I'm going to stop my recording, but if you want to hang around, you can ask questions if you'd like.